All right, everyone. Sorry I can't be there today. My son is actually home sick with me right now, so hopefully I'll be back tomorrow um, to help out with any sort of retesting or looking at tests for the momentum and all that jazz. Hopefully I'll be back soon, but I'm not able to come in today. So what are we going to do today? We're going to take the group test, and you will have an hour for that. You'll have 60 minutes to get that done, and then the rest of the period we're actually going to do something. No, we don't normally do it, but we're going to jump in because we're running out of time between now and the AP test. So we're going to jump into a little bit of electricity. So let's get right into it. For the group test, we know that it's always random groups. So on the next couple of slides here, I'm going to have the listing of who you're with, and so let's get into that. So if you are 1A, then here is your listing, and I'll leave this up for a few seconds so that the substitute can pause it. If you do not see your name on this list, that means that you are maybe a person who hasn't taken the test yet because you were absent, in which case you need to check with the substitute to see if you're on the list to go over to Miss Rittenhouse so that you can take that test right now. So that's 1A. Here's 2A. If this is 2A, again, we had a lot of people who were absent for 2A, so if you're not on this list, then that means you were absent, you haven't taken the test yet, and you need to go to Miss Rittenhouse right now in C203, just next door, so that she can make arrangements for you to take the test right now. Here's the listing for 3A. So if you're in 3A, this is where you need to go for the lab tables. The substitute will be around in just a couple minutes as you guys are working to give you what your student ID number is at each one of the lab stations. All right, so here's where the substitute is going to pause the video. You'll have 60 minutes to go and take care of your group tests. The substitute will have a timer, and you need to make sure that you're finished before then. If you finish before then and you have it turned in, then you can go ahead and grab a Chromebook, but wait for further instructions before you do anything with that Chromebook. All right, welcome back. So you have finished the group test, and we are going to jump into a little bit of electricity. And what we're going to do today is basically a virtual lab. So what the substitute is handing out right now is a lab that looks like this, single sheet front and back, and we are going to be doing a little virtual experiment. So what we're going to start off with is we're going to start taking a look at the force, we're back at forces, the force between two charged objects. So we call that the electrostatic force. And the way that we do this in the physical lab is we use something called pith orbs or pith balls, as you can see, which are basically little styrofoam objects that are super light, but can hold onto an electric charge. And I'm sure you know just from previous classes or your own experience that electric charges will exert forces on one another. So we are going to go to this website right here, explorelearning.com, and here's what it looks like when you first get in. You will click on login or enroll, and we have a school set of logins. So it'll bring up a little box that looks like this, and here's what you're going to do. You're going to put in something that's a username LHS student, and then a 3-digit number. And that 3-digit number can be anything, pretty much between 1 and I think like 200 or something like that. If it doesn't work for you, then back it off a little bit. Everyone's going to need to pick a different one, so if you happen to pick the same one that someone else in the classroom has, you can't have 2 logins on the same account. But it's LHS student and 3-digit number like 056 like I have, and then the password is literally the exact same thing. So LHS student 056 with the password of LHS student 056. Again, it could be 064, it could be 001. You just need to pick a number that it would work. And when you get in, you'll see a page that looks like this, minus that box right there. Basically, you'll need to click on Find Gizmos at the top, and that'll bring out the box that you see right there. And then you'll need to start searching for the gizmo, and the gizmo is called the Pith Ball Lab. So as you start typing it in, you'll see that it actually pops up like that. And so you'll just click on it, and it'll bring up a page that looks like this. You will hit Launch Gizmo, and it'll bring you into a gizmo. It won't start off necessarily like this. I've already messed around with some sliders. So Q1 and Q2, these are the charges that are sitting on the two pith orbs. And we'll talk more about what that means, but basically there's an excess amount of electrons or a lack of electrons if they're positive charged. And so they're, in this case, repelling one another. So I have moved those sliders to two random numbers, and you'll write those down on your sheet. Those will not change from here on out. So whenever you move them to those numbers, you just keep on those numbers. This number, the mass number, will actually change in the lab, and I'll show you that here in a second. You want to make sure that you are checking these two boxes, the show angle, and the show geometric dimensions. The main geometric dimension that we're going to be looking for is r. So r is the distance literally between the two objects. So that takes into account the distance w as well as any extra distance that we get from the fact that they're at an angle. So what are we doing? We're looking for the relationship between the electrostatic force and the separation of the pith orbs. And that separation is the r. So what we're going to do, as you can see from our table down here, is that we are going to mess around with mass and see how that affects angle r. And then we have this extra thing that we are going to use to calculate what the electrostatic force is. So we have mass, we have angle, we have r. So usually in an experiment, we change one, see how it affects the other. And the easiest one to change here would be our mass. So I would pick various number of masses that would fill out your table. Yes, make sure you fill out the entire thing. That way you have enough data to work with. And for every mass that you choose, you write down the new r and you write down the new angle. But we need to be able to calculate the electrostatic force, right? So here's where your free body diagrams come in that you are asking to be done on part of the lab. I think it's at the top of the backside. So let's do a free body diagram of one of these pith orbs. So if we have the force of gravity that's going to be coming down, we definitely know we have tension that's going to be going up with the the rope. And then we have this repelling force, this new force that we're talking about. This two positively charged objects repel each other. And so there's this new force. I'm going to change up the color a little bit. That way we can accentuate what I'm talking about. And that is we have this new force called the electrostatic force, Fe. Now here's the deal though. We don't know what Fe, we don't know how to calculate Fe just yet, but we know that these pith orbs are hanging out and they're just in equilibrium. We know that the tension force, being at an angle, could be written so that it has a part of the tension, Ft in the x direction, and a part of the tension in the y direction, Ft in the y. And we know a couple things. Fty has got to be equal to Fg, and Ftx has got to be equal to Fe, and we know what that angle is, right? So if we know the angle and we know Fg, because Fg is just mass times the acceleration due to gravity, then we should be able to use a little bit of geometry to figure out what Ftx is. And if we know what Ftx is, we know what the electrostatic force is. And so that is what we're going to do. Knowing the angle and knowing the mass, we can find Fe. Now once we have Fe, then we are looking for what the relationship is between Fe and r. And the best way to do that would be to graph them, right? So what I would do is I would graph the electrostatic force versus r and see what it happens to come out to be. I will tell you that if you freehand this, you're more than likely going to be looking at a graph that you will assume is one way when it's actually not. So what I would suggest you do is use like an Excel program, Google Sheets, or a graphing calculator, and actually run an analysis to see what sort of a regression to see what sort of function this actually is. Okay, so what your homework is for this lab is to get all of your data taken, get your calculations done, and you get your graph done, and then we will talk about what this is when we get back into class the next time. All right. I guess I will see you later. All right, thanks.